Hello everyone. So today we're going to continue to do some more questions around derivative theorem of e to the power of x. So yesterday we have gone through the two formulas, and I proved the two formulas too. And if you are interested in how to prove it, then you can go back to yesterday's video. And now the first one is y equal e to the power of x, then y dash equals to the same. And the second one is y equals e to the power of fx, then y dash is equal to e to the power of fx times f dash x. So these are the two formulas. And now let's try some question. So there's a function which is y equals x times e to the power of negative 5x, and we need to differentiate this. So let's write y dash. Well, for e to the power of negative 5x, we can use our formula. However, there is an x in front of it, so we can't just use the formula straightly. So how do we do? Do you remember our product rule, which I talked 2 lessons before? So the product rule is u dash v plus uv dash. So now let's apply this, which becomes x dash times e to the power of negative 5x plus x times e to the power of negative 5x dash. And x dash is equal to 1, so we have e to the power of negative 5x here, and plus, well, now we are going to use the theorem to solve this. And so here it's negative 5x here, so we can't use the first formula, so we need to use the second one, which becomes plus x times e to the power of negative 5x, the same, and then we need to time f dash x. So what is fx here? Fx is actually negative 5x, so we need to times negative 5x dash here. And this is equal to e to the power of negative 5x. And here is negative 5, so you have negative 5x times e to the power of negative 5x, which is e to the power of negative 5x times 1 minus 5x. And we solve it. So this question is not very easy because you need to apply the product rule as well. And if you are not familiar with product rule, you can go back to my videos and check as well. So now let's do a question that is around medium and hard level. So it is find the gradient of y equals 8 over 5 plus e to the power of 2x at the point where x is equal to 0. This is another question that is around gradient. So same thing. If we want to find the gradient, so what should we find in order to find gradient? Well, we need to find the differentiation of this equation. So let's try this. So let's try to solve the differentiation of y. And here it's a fraction, which means that we need to apply our quotient rule. So what is quotient rule? It's v squared, it's underneath, and u squared v minus uv squared. This is our quotient theorem. So now let's apply this, which becomes y dash equals to 5 plus e to the power of 2x bracket squared, and then it's 8 up, so when you, here is dash. So when you do 8 dash, it becomes 0, so the first term disappears. So now what we left is negative 8 times 5 plus e to the power of 2x dash. And this is equal to 5 plus e to the power of 2x bracket squared, and negative 8 times, well, we know that 5 will differentiate will become 0, and e to the power of 2x will become 2 times e to the power of 2x according to this formula, because when we need to time f dash x, so f dash 2x is equal to 2, so we times the 2 at the front, and now we have negative 16 times e to the power of 2x over 5 plus e to the power of 2x bracket squared, and that is our y dash. However, what the question is asking, which is find the point where x is equal to 0. This means we need to find f dash 0, because this just means at the point x equals 0, what is the gradient of y? And let's substitute x. So it becomes negative 16 times e to the power of 0 over 5 plus e to the power of 0 bracket squared. And we know e to the power of 0 is equal to 1, so this becomes negative 16 over 36, which is negative 4 over 9. And this is our gradient. And we solved it. Okay, so now let's move up to a new topic, which is the differentiation of ln x. Well, we learned ln x in previous topics, so it is another symbol for log base ex. And so how do we do the differentiation of ln x? Well, here is the formula here. If we have y equals ln x, then y dash is equal to 1 over x. Well, to prove this is quite easy, because let's prove it. So we have y equals ln x. Well, proof. And because we learned in the previous topic, so we can, if y equals ln x, then we can say that x is equal to e to the power of y, because ln x is equal to log e base ex, so we can express x as e to the power of y. And now let's do differentiation on both sides, which we have dx over dy equals ey dash, which means, so x dash, which means this remains the same and it still equals ey. And now for dx over dy, let's flip it. So let's do its reciprocal, which becomes dy over dx. And here ey, it will become 1 over e to the power of y. And we have assumed, now assume we got that x equals e to the power of y. So we can change e to the power of y by using x. So we will get 1 over x. And dy over dx, we know that this is equal to y dash, so which means y dash is equal to 1 over x. And this is the proving for ln x. Okay, so this is all for today, and tomorrow we are going to do some more questions around ln x differentiation. And if you are interested in GCSE math, you can go to the channel by Daniel Dallas. And thank you all.